Alright class, this is the first day of simplifying fractional exponents. The first thing we're going to do, we had the video last night that was all, so this is going to be kind of a warm-up real fast for number 1 and number 2. Remember on the last day of notes I said you can flip everything if you want because it's raised to the -3. So that's the first thing I'm going to do. I'm going to keep the negative on top though, that doesn't really matter. So I'm going to put everything on top that was on the bottom. Now there's two things you can do. You could raise everything to the third power now, or you can simplify this fraction and then raise it to the third power. I'm going to simplify, so I get -2 over 1. A to the 4th goes down with the A to the 5th, so there's an A to the 9th down here, and then there's just a C to the 5th up here because C to the 0 is 1. Alright, now that I'm here, -2 to the 3rd is -8. C to the 5th to the 3rd, you multiply the powers. 1 is still 1, and then A to the 9 times 3 is A to the 27th. So that's the final answer. Same thing here. I'm going to simplify everything first. I get 4a, I'll just rewrite this one first, over 3 squared is 9, a squared is a squared. Times, I'm going to start simplifying this. They both divide by 2. So I'm going to say it's -3 over 20. I have 5 a's down there and 3 up here, but they're negative, so they have to go down with the 5. So there's now 8. Remember, you're adding or subtracting. 7 c's down here, but they're negative, so they go up. So I have 12 up here because there were 5 and now 7. And d to the 5th is down here, but it's negative, so it has to go up, and there's no other d's up here, so we're going to say d to the 5th. Okay, so that's where I'm at now. Now you can multiply across, so we get -12 over 180. I have an a, an a squared, and an a to the 8th. So I have 10 a's on bottom and 1 a on top. So that means I'm going to have 9 a's on bottom. D's stay on top, so let's look at the c's. I have 12 and then a -4. You can think of the -4 as 4 below, or you can add the exponents. 12 plus a -4 is c to the 8th. And then finally we have d to the 5th. And then I'm not done yet though, because guess what? These numbers simplify. You get -1 over 15 for your fraction. And now we are done. Okay, so those are the from the old notes. No fractional exponents yet. So now we're going to be working with roots and fractional exponents. So you guys should know that 4 squared is equal to 16, and that the square root of 16 is equal to 16 to the 1/2, or it's going to equal 16 to the 1/2 power. And if we rewrite that as the same base, 16 is 4 squared to the 1/2, and then if you do power to a power, you just get 4. So the square root, n is your index, and that is for this problem 2. Okay? For this problem, n is 3, so I want the third roots, we call it, or we're raising 8 to the third power, because 2 to the 3rd is 8, so if we go backwards, if I raise 8 to the 1/3, again, we can turn 8 into 2 cubed to the 1/3, and sure enough, 3 times 1/3 is 1, so we just get a 2. Okay, and then same thing here, we raise this to the -3rd, so with negatives and odd powers it stays negative. So that means that if I take a third root of a 27, that turns into -3 times -3 times -3, and you get just -3. So here's what you have to know. We say it's the nth root, or that the number is the index. So we're taking the third root, fourth root, fifth root. That means that you have to have that many pairs to bring it outside the root. Okay? Or I shouldn't say pairs, that many of that number. Usually when we did square roots and you did the factor tree, you found pairs. Now you're going to find however many you need. So first we're going to just rewrite these in the different forms. So a to the third root of a is the same thing as a to the 1/3. The fourth root of a is a to the 1/4. The fifth root of a is a to the 1/5. So this is now b to the 1/12. The index is 12, so that's the same thing as saying I want the 12th root of b. The 1/2 x to the 1/2 is same thing as saying I want the square root of x. Now, with square roots, you do not need to put the 2, but for this lesson, I'm doing it just so you see how it works. Be careful here. All these things are not raised to the 1/6 power. It's just the y. So the 4 and the x are not under a root, but the y is. The y is under a 6th root. Okay? We want to make sure that we can do that. Alright, so I'm going to not show the calculator, but in the calculator, type in 100 to the 1/2 and you get 10. And you should know that the square root of 100 is 10. So here's how you're going to do it by hand. You want to get it so that the bases are lower. So we know that 100 is 10 squared. So this is just by hand what happens. 100 is 10 squared, but now we're raising it to the 1/2 power. Power to a power is just 10 to the 1st power, which is 10. You could think of it down here too. I have a square root, and I have 10 times 10, or 10 squared. I have a pair, or 2 of them. Actually, let me write it as 10 squared. So the index is 2, and I have 10 squared. Because I have enough to pull it out, I'm left with 10. So let's see what happens here. If I use my calculator, I get 2 and 2. And I'm going to show you guys in class how to do this on the calculator. I just don't want to waste time on the video right now. 64 to the 1/6. First of all, you need to know what 64 is broken out into. You should know that 8 is 2 cubed and 2 cubed. So there are 2 to the 6th powers, or it's 2 to the 6th power to the 1/6. When you do power to a power, you're just left with 2 to the 1st. Same thing here. We know that 6th root of this is 2 to the 6th. Since there are 6 2's in here, and we need 6 of them to pull it out of the root, we have a perfect match, so it turns into 2. So when the index matches the power, you have no radical anymore. Okay? Now, let's go on. So now this says find the nth root of a. So a is 32, negative 32. So I'm finding the 5th root of negative 32. Again, to do these, you have to turn the number into the smallest possible base number. 8 and 4, that's 2 cubed and 2 squared. So we get the 5th root of negative 2 to the 5th. Again, if you can't see it in this format, you can rewrite it as negative 2 to the 5th to the 1/5. And sure enough, these cancel, and you're left with just negative 2. So the nth root of a is negative 2. The 3rd root of 64, again, let's break 64 down. We did that on the other page. 64 is 2 to the 6th. Alright, so this is different because it doesn't match, but do you see how there are more under the root? Okay, which means we can take some out. There are 6 2's under there. We only need 3 to pull 1 out. So that means we should be able to pull 2 of them out. So let's see what happens when we rewrite it in fraction form. You do power to a power, and sure enough, you're left with 2 2's on the outside with no root anymore. So the final answer is just 4. Okay? Finally, think about this. This is even. Can you take the square root of negative 16? No, right? It's an imaginary number. Same thing with even roots with negatives. Not possible, or no real solution. Let's write it like that, because there are imaginary. Okay, so there are no real solutions when it's even and it's a negative underneath the even radical. Okay, so now here are some things when you combine powers and fractions. If you have something to the m over n, you can rewrite it as, and we've kind of been working with it like this, a to the m to the 1/nth, or you can rewrite it in radical form, which is the nth root of a to the m, or if you want, you can do the nth root first and then raise it to the m. Okay? So the numerator represents the power that you're raising it to, and the denominator represents the root or the index. Okay? And it works the same thing with the negative ones. We have a to the negative m over n. Well, first of all, you can rewrite it in many different ways. you can say it's a to the negative m and then to the to positive 1 over n. You can flip it over and put everything on the bottom, and you can also write it in radical form. Alright, so when working with numbers, you must break them down to the smallest base as much as you can. So this is saying, you have to figure out which one's easier. This is saying take the square root of 16 and raise it to the 5th. The reason why I wrote it like that is because you can take the square root of 16. It's a nice number. So it's easier to break it down first. Try to root it first if possible, then raise it to the power. So what's the square root of 16? It's 4 to the 5th power, and you can just calculate that is 1024. So this one here is a negative exponent, so first thing I'm going to do is bring this down, and I'm going to say that I have 64 to the 2/3. Now we have to turn 64 into something. 64 is 2 to the 6th. So we can rewrite this as 1 over 2 to the 6th to the 2/3. If you multiply this, you get 1 over, these powers go away, and you get 2 to the 4th, which is 1 over 16. There's many different ways to do this. You could have third rooted the 64 and then squared it. The third root of 64 is actually 4. And sure enough, 4 squared is also 16. So it doesn't matter which route you go. Laws of exponents apply to these exponents as well as integer exponents. Okay? Remember, keep your answers should be in simplest radical form. No radicals on the bottom. When we simplify, we divide the exponent by the index. Okay? So here's what happens. I want to simplify this radical. When we used to break this down, we would just find out what this broke down into, and we would have all of our base numbers. So this is 2 cubed, and this is 2 squared. So this is basically saying we have the cubed root of 2 to the 5th. How many do you need to pull it out? We need 3 of them. Okay, so what I was saying here, when we simplify, divide the exponent by the index. So 5/3, is that bigger than 1? Yes. Is it bigger than 2? No. So that means that we are definitely using 3 of them to pull a 2 out. And how many did we not use? We used 3/3, and we need the other 2/3 are left. So what happens is, we use 3 of them, we have 2 left in here. So when I used the 3, when I say 3, that means 2 times 2 times 2. There was 3 of them, 2 to the 3rd. That got pulled out and simplified to a 2 to the 1st, or 2. And then I'm still under a third root, and 2 squared is now 4. So that's how you simplify those. Let's do another one. Again, it's all about breaking these numbers down correctly. 648 is 8 times 81. You can use your calculator to figure that out. 8 is just 2 cubed. 81 is 9 times 9, or 3 squared times 3 squared, which is 3 to the 4th. Always break it down to the smallest number. So I have both of those things under a third root. Nice thing is, we have 2 to the third root. So here's what you can think of it as, if it helps you see this. You have that. So what happens is you get 2 to the 1 times 3 to the 4/3. If 4 divided by 3 is bigger than 1, you're good. You can pull 1 out. So that means that I'm going to have a 2 and a 3, but I still have a 1/3 left over, because 4/3 is 1 and a third, right? 1 and a third. So this 1/3 has to stay under the third root, because that's what this 3 is. It's the 1/3, and there's 3 to the 1st power left over. So to simplify fully, we have 6 third root of 3. Alright, last page. There's a lot of these. Again, we're just going to be doing all the different exponent properties. I'll try to do them all. It'll be a long video. Alright, 7 to the 1/2 times 7 to the 2/3. Common base. If you multiply bases, you add exponents. In order to add exponents, though, you need a common denominator. We just went through adding. 1/2 is the same thing as, we can get it into sixths, 3/6. 2/3, if you multiply both of them by 2, you get 4/6. So you get 7 to the 7/6. You can think of that as 7 to the 1 and 1/6, right? There was enough for 1 with a remainder of 1. Which means that I have a 7 outside, a whole 7, but I am left with a 6th root of just one more 7. That's what this number is. And that number goes here. Okay? Okay. Remember, you cannot multiply bases together unless they are the same. So instead, we're going to have to work with the numbers separately. So first thing I'm going to say is, well, 27 is 3 to the 3rd. Okay, 6 is just 6 because it's a 2 and a 3. Actually, we can break it down, but it's a 2 to the 1/4 and a 3 to the 1/4. Okay? Now we're going to square this. First of all, this goes away right here. So 3 squared is 9 times 2 to the 1/2 times 3 to the 1/2. We can put these back together because they are the same exponent and say we have a 9 on the outside and a 6 to the 1/2. You can only multiply numbers together if they are the same exponent, or you can combine them if they're the same base by adding the exponent. You cannot multiply like these two together just because you want to. Okay, this doesn't work. So we can rewrite this in radical form. We have 9 and then the square root of 6. And you can put a 2 there if you want, or you don't have to. It's up to you. Okay, again, these are not the same bases, but we can make them the same base. This is 2 squared and then to the 3rd. So this is 2 to the 6th times 2 to the 3rd. Now we have the same base. So we can add our exponents. We have 2 to the 9th to the negative 1/3. Since this goes together nicely, I'm going to multiply power to a power and say I have 2 to the negative 9/3, which is negative 3. Now we go, oh, okay, that's a negative exponent, so that means that that goes to the bottom of the fraction, which we don't have, so we're creating it. It's 1 over 2 to the 3rd. I wrote 8 because 2 to the 3rd is 8. So our final answer is 1 over 8. 1 over 8. Okay? Here, you have to think of this as this is 6 to the 1st power over 6 to the 3/4. Now, you could try to put that in radical form and rationalize, but we haven't learned that yet. We're going to learn that tomorrow. So right now, we're just going to use our exponent properties and know that you're going to subtract the exponents because they're the same base. So this is 4 over 4, right? And then 4 over 4 minus 3 over 4 is 6 to the 1/4, which is equal to the 4th root of 6. Now, just double check to see if this breaks down further. It's only a 2 and a 3. We don't have 4 of something, so that's our final answer. Just the 4th root of 6. Okay. 162, we got to break that number down. I don't know what's going on here with this. So if you take 2 out, you get a 2 to the 1st, and then we get 81, which we've talked about already, is 9 squared, or 3 to the 4th. So here's what I have. I have a 2 to the 1st and 3 to the 4th. 1 divided by 3, it can't come out. There's only one of them. 4 divided by 3 is 1 1/3. So the 3 to the 1st comes out, the 2 stays under, and there's one more 3 left over because we used 3 of them to pull it out, and we have 1 left. So we finally can say that my final answer is 3 and then the 3rd root of 6 because there's nothing else we can do. Okay, this one here, not the same basis. However, they are the same power. Remember when we have square roots and we multiply them, we can multiply numbers under square roots, inside number by inside number? Same thing. If they're the same power, you can multiply the numbers. So it's the 3rd root of 125. 125 breaks down into 5 to the 3rd. So since we have the 3rd root and 5 to the 3rd, these will cancel, and our final answer is just 5. The 4th root of 64, we need to break 64 down into 2. By now, hopefully, you know it's 8 and 8, or 2 to the 6th. Okay, so if you like to work with it like this, that's fine. You could also rewrite this as 2 to the 6/4. I'm going to simplify that to 2 to the 3/2, which is the same thing as saying I have 2 to the 1 and a 1/2. Alright, the 2 to the 1 comes out, and I have a square root of 2 left, because that's 1/2. 2 to the 1/2 is 2. So that's it. Here, these problems are not that bad, but some of you guys do crazy things on these, and these will pop up. You cannot do anything with the 10, the 6, and the 5. They are all different numbers. These two have the exact same exponents, so you could have divided them if 6 divides into 5, but it doesn't, so you can't. When working with a bunch of different bases, you want to get the smallest factors. Get them down to the smallest factors. So what is 10? 10 is the same thing as 2 to the 3/4 times 5 to the 3/4. So that's what this 10 turned into. This 6 is going to turn into a 2 to the 1/6 times 3 to the 1/6. This 5 doesn't do anything because you can't break 5 down. 5 is just 5. So now we have bases that match. So you look for the bases that match. 2 to the 3/4 and 2 to the 1/6 on top. When you multiply those together, you add the exponents. So I'm going to turn this into 12ths. So this is 2/12, and this is, to get this to a 12, you need to multiply by 3, so this is 9/12. So when I add those together, I get 2 to the 11/12. Alright, so we're done with the 2's now. We've done what we need to do with them. 3 is still 3 to the 1/6. However, you need to, here's another rule. At the final answer, you need to have the same index. You need to have the same index. So, I have 3 to the 2/12, I'm going to call it, because I don't want to have it in sixes, or sixths. Finally, we have the 5's. Now we're going to be subtracting these exponents, but first we need to change them into 12ths. 9 minus 2 is 7. And I get 5 to the 7/12. Now, notice how all these fractions are smaller than 1, which means nothing can come out of this. So I can rewrite it in radical form. The 12th root of 2 to the 11th times 3 squared times 5 to the 7th. And again, you cannot multiply those numbers together because they are different powers. So, and this is going to be a really big number, so we're going to leave it like that. Don't multiply that out in your calculator and give me some crazy number. I don't need it. Now, this one here, since they are the same root, you can divide first. So this would turn into the 3rd root of 8, which hopefully you guys by now know that 8 is 2 cubed. And since it's a 3rd root of something cubed, they will cancel perfectly, and we're left with 2. The 6th root of 49. The only thing we can do here is turn 49 into 7 squared. So some of you guys are thinking, well, that doesn't do much because we don't have enough to pull it out, so it's still stuck under there. Yes, that's true, but you can simplify this. This is 7 to the 2/6, which simplifies to 7 to the 1/3. So that means that that is what it simplifies to. However, I want you to write it in radical form, always. So we have 3rd root of 7. Okay. So those are a bunch of different examples of what you can do with powers of fractional and nth roots and different roots that we haven't been dealing with before. Okay, just remember that roots are fractional exponents.